The last topic related to functions in this course covers the so-called subfunctions and nested functions. It might be that you will not be using them, but it's good to know that they exist in case some of you find them useful in the future. So let's start from subfunctions. The idea here is that a function file can contain more than one user-defined function. So now we really focus on function files in here. When we had functions written within a script, I already showed you that you can have one function after another, and then each of them has to be ended with an end. But that's also the case in a function file, that you can actually have more than one. And they are also typed one after another. And each function begins with its own definition line. Now the difference is that when they are in a function file, then it is still not necessary to actually end each one of them with the end command. It is necessary if they are part of the script file, but it's not necessary when they are in a function file as such. And then the first function on the list, because you will end up having a number of them, the first function on the list is then called the primary function, and the rest are so-called subfunctions. And then the name of the function file should then correspond to the primary function name. So the first one on the list once again defines how you call your function file, and the other ones can be anything. And then when you have many functions within a file, each function can see and use any other function. So they are kind of available for each other, but you cannot call subfunctions from outside the function file. So you can think of that they are kind of supporting for the maybe main function or for each other in the function file. But when you call the function in the script, you can only call the primary function. So here is an example. We have 3 functions in one function file, and the first one is called stat, and it kind of collects statistics of some vector. So let's say we give vector v, and we would like to calculate mean value and standard deviation for that vector of values. And now for my average, or the mean value and the standard deviation, I have 2 subfunctions, each defining those. So now the average is basically the sum of my elements of a vector and divided by its length. So that's straightforward. And you can see in here I have x. I could have used v as well, but using a different name is fine, because again, kind of these variables become just local for this particular function. And then we have the standard deviation. So again, I have x. Then I also kind of use the average of the vector already as an input, even though it could have been calculated in here, but this is just to show you that you can use for given functions also outputs of other ones. So here when I call standard deviation, I give the vector, and then I give its mean value calculated using the average. So my standard deviation calculation is based already on a given average, and then the final formula is here. Now, how does it look in practice? I have it written in here already. And so we have the 3 functions. My first one, so the primary function, was called stat, and you can see that that's exactly the name of the function file. And I don't have ends after each function. I can put those, but as I said before, they are unnecessary. So then if we try to call them, let's create a file that will be our main script. And so let's define a vector. Okay, and then I have stat of that vector. Now, using this chance, I'll also show you, for instance, what happens if your function, and it doesn't matter, do we now talk about subfunctions or anonymous functions or whatever, if your function is supposed to have more outputs than one, but you don't ask for all of them. So in here, I don't assign my output anywhere. What will happen is that the first of the two outputs will actually be assigned to variable ans, so being that default answer variable, and the second one will actually be ignored completely. So now if you see, ans here actually comes from the function. Now this AV and the same value actually comes from within the function. It means I have forgotten to include semicolon somewhere inside, which is in here. So that's why we saw it displayed, but you see AV as a variable doesn't exist because AV is local. So I'll put the semicolon in here, and once again I have forgotten to have space for two outputs, so that's why only first one went there to ans. Now I'll remember I want mean value and standard deviation from my stats. So now when I run it, indeed m gets value of the mean value and s gets the standard deviation. Okay, but within my stats function I had that average function, and as I told you, you cannot access it. It's not visible. It's only local for the stats function, and it can be used within in here, but it cannot be used outside. So in that case, we are getting an error if I try to access this average. And now let me show you that, for instance, if I have now those ends, it will work again. Now, if you end at least one of them with an end, then you have to follow with all of them. You can't choose that some of them have ends or not, either all or none. So when I run it in this way, of course, I get my first two, and then again the error comes from this average. So the fact that we put the ends doesn't change anything when it comes to locality of the functions within that. All right, so these were the subfunctions, and now the other case, which are the nested functions. So nested functions are a little bit similar to subfunctions, but now the idea is that again we have a primary function, and that one defines the name of our file, but the supporting functions are now inside of it. So it's a little bit like nested loops. If you remember, we had a couple of examples when we had two for loops, one inside the other. So now in here we have this outer function, which is called primary again, and then we have this inner function. So that one is called nested function. So if we use the same example of having, again, the statistics of vector calculated, and then we have those supporting functions inside. So you can see that now those two have their own ends, and then my primary function has its own end. But the interesting thing is that when we talk about nested functions, the variables within the primary function and nested functions become global for that primary function. So for instance, you see I have n here, meaning the number of elements in my vector, and then I can use that n here without having to define it separately in my smaller functions. The same here, I needed that mean value for the standard deviation calculation. In my subfunction case, I actually had it also in here as an extra input, but now I can use it directly from my primary function because they are global, kind of local. They are locally global, if we can say that. And also you can notice that it doesn't matter whether you define your nested function after the place where you actually use it, or maybe before, like in here. It's okay either way, because that the code will work anyway. That's something unusual when compared to what I've been trying to teach you, that you always write the code in the order how you need values in order to calculate the next values. When it comes to nested functions, at least the locations of those subfunctions don't really matter, because Matlab will understand it anyway. So I have this example also coded in here already. So I have my stat2 function, and you can see now what I said before, that for instance this n is global and it shows in this kind of light blue color or cyan. And for instance, now that mean value is available here, so I still have a bit different version where it is kind of given as input for the standard deviation calculation, but I can remove it and I can use this directly in here as the mean value calculated by this average function. And you can see that it also immediately changed the color. So now Matlab recognizes that this is the global variable locally within my primary function, and it's perfectly fine to use it. So if we try to call this one in our script, I can again have ms, or let's call it m1s1, and my function was called stats2, and again let's give it the vector, or was it stat2? Yeah, so you can see that the values are again the same, because the functions were after all doing the same job, they were just written differently.